As is true for all configuration XML files, modules that are loaded later can override configuration values of modules that are loaded earlier. In the context of di.xml preferences, this means a module can provide an alternative implementation for an interface by overriding the default preference. Then the alternative implementation will be used everywhere instead of the original class. Let's have a look at an example. Here is a dummy customer repository implementation. So this is just a dummy. It simply returns a single hard-coded customer instance. So this dummy customer that is hard-coded in the dummy customer factory. In reality, a custom implementation would be querying a different data source other than the Magento database, and would also have to implement all required methods not only as method stubs, but by providing the real expected functionality. But for now, for this example, let's configure this dummy repository as the customer repository interface. So I'll start by copying a reference to both the customer repository dummy and to the customer repository interface. And now we have to create a di.xml. I'm using my di.xml file template here. And now I can declare the preference for the customer repository interface to the customer repository dummy. I'll remove the leading backslash again. Okay. Because our intent is to override the default preferences which are set in the Magento customer module, we also have to add the Magento customer module to our module's sequence node in the etc module XML file. So now our example module is loaded after the Magento customer module, so our preference configuration will override the original. For more information on module load order and XML merging, please refer to the videos on those topics. Now let's go ahead and disable and enable the module again, so the app etc config.php file is regenerated with a new module load order. Now, let's try it out. I'll copy a reference to the customer repository interface again. And once the console is ready, let's use the ObjectManager to create an instance of the customer repository interface. And yes, indeed. Okay, so far so good. Our dummy repository is returned. But let's see if our dummy repository is also used by Magento now. Magento has a quote class. All quote instances are associated with a customer. The quote getCustomer method uses the customer repository interface to retrieve the associated customer. So this is the quote model. Here's the getCustomer method, and here we can see customer repository getById is used. Which means if we instantiate a quote and call getCustomer, our hard-coded dummy customer should be returned. Now, to instantiate the quote object, the area code needs to be set. I won't go into detail right now on the application areas, but if you are following along, feel free to try it without setting an area code and you'll see another error message. Application areas will be covered in a separate video. For now, let's just go ahead and set the area code. For this we need the Magento Framework App State instance. And now we can set the area code. We only have to do this if we're working in the REPL or on the console. If we're working through the browser, that's taken care of automatically. So now let's go ahead and create a quote. All right, let's call getCustomer. Well, it gives us a customer. I'll assign that to a variable so we can inspect the values. All right. Yeah, the quote uses our customer repository dummy. Now, in reality, exchanging a single interface implementation usually doesn't work that easily. The reason is that Magento core modules don't always rely only on the API interfaces. Not within a module, and also not even between all modules. Instead, the concrete classes are used in many places. So, changing an interface preference to implement a big change in functionality usually isn't enough. This is so because of performance reasons for one, and also probably because of some Magento 1 legacy. To resolve this problem, the core team has declared application components, each of which is comprised of a group of modules that depend on each other's concrete implementations within a group. So here we have a diagram, and between component boundaries, the APIs are used. But within a component, modules may depend on concrete implementations bypassing API interface preferences. So for example, the customer analytics module may depend on the concrete customer repository implementation. Or it might even query the customer database tables directly. Whereas anything within the admin module or modules from the catalog component, they would use the customer repository interface when needed. Please note that every module belongs to exactly one application component. So this componentization of the application is a work in progress. We have to keep in mind that the grouping of modules might change after this video is published. We have to be aware that if we change the preference for a core API interface to work with a different data source, we probably also have to replace most or all of the API implementations of the other modules within the same component group as well.